Well, that leaves us with the big question. What do? You're a deployer of Swift, and you've got drive vendors saying, we've got this new hotness. It's this greatest thing. So the question is, should you go buy them? And should you deploy them in your Swift cluster? So in general, based on our testing, you're going to, I think, not be surprised by some of the stuff we'll say here. So our recommendations are that, number one, in a general use case scenario for Swift, you should not use SMR drives. The performance hit that you get on those, especially when you're dealing with the smaller objects, especially as we've seen the distribution of object sizes inside of Swift clusters, is not worth the additional capacity that you can get by the increased density of those drives. But drive manufacturers actually aren't even selling these as general purpose drives, so they're not lying to you. It is very, very good. These things are sold as archive drives. These are things that are designed for a particular use case. So there are some use cases that this could be very good for you. And specifically, it would be, do you have a workload that generates large files, and large being 4 megabytes or larger files, and it does something that writes and potentially can read. Reads, remember, can be okay. For example, maybe you have backups. I know there are a lot of different backup vendors out there, and I've worked with quite a few of them. But specifically, I know that Commvault has the ability to have very large writes. And with backups, you're looking at kind of this worm data. You write it once, and you read it many times. You don't try to overwrite. You don't try to keep updating the data after you've written it once. So it ends up being a pretty good use case for SMR drives. Another one would be potentially like video surveillance cameras and things like that. They generally can output about 1 megabyte a second. And so that would be a great use case for SMR drives, especially when you configure those to, say, like every minute or every 100 megabytes or so, cut it off and write a file down, persist that, and then keep streaming to the next one. And other use cases that I've seen, kind of like the big data, like genomics and DNA things, and you've got these huge data sets. I think the genomics thing is very interesting because you've got these very massive data sets. I would not put the SMR drives in the path of the high-speed analytics and comparisons and that kind of like very small files that are reading and writing things, but that full sequenced genome that is gigabytes in size, not a bad case for SMR. So the point is there are actually some reasonable use cases that people are doing today that would be an interesting fit and something to consider for SMR drives. And if you wanted to start doing that, if you wanted to start experimenting with this and figuring out, okay, well, I might want to gradually ingest some of these SMR drives into my cluster, how would I do that? Step one would be set up a storage policy inside of Swift. We've got the storage policies that allow you to isolate a particular set of drives from the rest of them. So you would set up a storage policy that would be set up as, this is going to be my backups storage policy or something like that. And then as you generally buy or as you gradually buy the SMR drives, you can put those into that storage policy alone. Then any kind of data that's written to that storage policy, you just make sure that the applications that are writing into that storage policies are the ones that are doing the large files, not a lot of overwrites, doing the big files. It's kind of that sort of thing. So, like I said, I think that there are some good use cases out there that you could, but probably not for a general purpose. Great, let's just start buying SMR drives because they're going to have a little bit more capacity available today. But that does mean that what does the future work? What can we do to actually improve this and make this a better story for everyone? And so there's quite a few things that I think that are obvious directions. Some of them aren't very simple, but some of them are fairly obvious. One of them is something that I think that we're very interested in Swift overall anyway, and in fact, some of the Rackspace developers have been working on their Go language Hummingbird server have already implemented some of this, and that is being able to restrict down the number of connections to a particular drive. In general, if you said, if we could rate limit a particular drive such that every day it's only going to average 8 megabytes a second, then look, we're right in the zone of what's good for SMR drives. Now, if we could bring that in and make that a little more configurable to the operator and to the deployer, I think that's something that would be widely usable for a lot of people inside of Swift.
So all the work we did so far, so we were using the drive managed SMR drives, so we saw certain performance, and we did a lot of work ourselves in order to manage the drives themselves. However, the next logical step, which is being developed nowadays, are file systems that are aware of the SMR drives. So they will go and do all these optimizations themselves. So what we need to wait for now is for these file systems, at least the first versions, to be available and get them and run all these tests again and see how those file systems perform. Because many people will use them for sure, and they're going to really solve some of the problems that we saw during our tests here.
And then I think finally, kind of the pie in the sky, multi-year time frame horizon of what could be possible is that after you have particularly done some small level rate limiting to a particular drive, after SMR file systems have been developed and you've tested those and deployed those and those have shown promise, well then what would possibly be next? And at that point, you're getting into the realm of things like, well, how would we teach Swift itself to speak SMR? And really what you're talking about here is you're almost substituting SMR for any sort of native memory, native media conversation between Swift and whatever that storage media is. And frankly, it's terrifying. That would be a huge multi-year effort inside of Swift that I don't think anybody is chomping at the bit to try to tackle. But because a lot of that will be taken care of, as Carlos said, by those SMR file systems to start with. So it's something that's definitely a possibility as far as this far future thing. And if you really want to commit some developers, several years of time to work on this in the community, patches are welcome. But that being said, I think that to summarize, what we've got is some interesting ideas for the future work, that some things that we, the developer community, can work on. We've got some good recommendations for what you today can take advantage of, in that, namely, don't use SMR for a general purpose, but use them for a specific thing. Use a storage policy inside of Swift to say that here are large files that have not really much overwrite, not a huge ingest bandwidth requirements, and those are things where you may be able to see some opportunity of benefit for SMR drives.